Okay. The Pew Internet and American Life Project finds 93% of teenagers use the internet, and 55% of online teens have posted a profile on the social networking site. What percent of teens are online and have posted a profile? Okay, so this is really one of those conditional. So it's what's the probability that a teen is online and has posted a profile? And that's really the probability that a teen is online times the probability that a teen has posted a profile given that they're online. So that looks confusing because it's kind of a confusing, but you know it's an and. There are only two probabilities given in this problem. So as long as you multiply those two probabilities, even if you weren't sure of the formula, then you're going to be fine. So that's 0.5115 or 51.15%. Okay? Again, what we're really saying is we know 93% of teens are online, okay? And 55% of online teens have posted a profile, right? So it's really 55% of this 93%. It's not 55% of all teens. It's just 55% of the teens that are online, okay? All right, a jar contains 4 blue marbles and 2 green marbles. Without looking, 2 marbles are drawn from the jar. What is the probability 2 marbles with the same color will both be selected? So in this case, it's a combination problem, right? So we could satisfy this by having a blue and a blue, or a green and a green. Right? So again, we've got an or and we have an and. So in the first case, there are four blue marbles, and there are 6 total marbles. But now, once we've chosen the first one to be blue, now there are only 3 blue marbles, and there are only 5 marbles in the jar. So you've got to make sure that, again, the second one is a conditional probability. So what's the probability the second marble is blue, given that the first marble is blue? Well, again, now my probability is only 3 out of 5. Or, all right, now the probability that I have a green marble is 2 out of 6. But once I choose one green, now it goes down to 1 out of 5. Okay, so this is what it would look like. 4 6 times 3/5 plus 2 6 times 1/5. And that is equal to 7 out of 15. Okay? 7 out of 15. All right, Bob tosses 3 fair coins. What is the probability that at least one of these coins will land on heads? Express your probability as a decimal rounded to the nearest 1,000. So remember how I said when you're talking about at least, that's a key for you to use none. Okay? So he's tossing 3 coins. And we're saying, what's the probability at least one of them is heads? Now you could go through and figure out all the possibilities, right? You could have heads, heads, heads. You could have heads, heads, tails. You could have heads, tails, heads. You could have tails, tails, heads. So many different combinations. But instead, we're going to use the concept that if we find the probability that none of them are heads, okay, none of them are heads, right? Which, because we only have 2 choices, means we're getting tails, tails, and tails. Right? So that's not heads. Not and not, right? So this is the probability of none, okay? So the probability that none, that's 0.5 times 0.5 times 0.5, right? Which is 0.125. That's the probability that none of them are heads. So the probability that at least one is 1 minus 1 minus 0.125, and that's equal to 0.875. Okay, 0.875. So again, on the test, when you see at least, all right, you're going to do 1 minus the probability of none. Okay? An instant lottery game gives you a probability of 0.02 of winning on any one play. Plays are independent of each other. If you play 3 times, what's the probability that you never win? Okay, so what we're asking is what's the probability that you don't win? And then on the next one, you don't win. And on the next one, you don't win. Right? Well, the probability that you don't win is 0.98. Okay, probability the next time that you don't win is 0.98. That's just 1 minus 0.02. All right, and the probability again that you don't win is 0.98. Okay, and that is equal to 0.9412 or 94.12%. Now, some students get confused, and because they see this negative, this don't win and don't win and don't win, they're thinking that's like the none. But we didn't see at least in this sentence. We didn't see at least in this problem. This was just saying straight up, what's the probability that you don't win? So there's no subtracting here. Our answer is just the 94.12%. This was not an at least problem. There are 100 students in the engineering club. 25% of them are commuters and 75% are dorm students. What's the probability if you choose 2 students, you will choose a commuter and a dorm student? We want this as a simplified fraction. So in this case, you have to remember, you could choose a commuter and a dorm student, or the first time you could choose the dorm student and then you could choose the commuter. Remember on the PowerPoint when we looked at all the different choices for rolling 2 dice, there were 36, not 18. So rolling a 1 and then a 6 was different than rolling a 6 and then a 1. This is the same concept. So we look and we say, well, what's the probability at first? There's 25 out of 100. There's 25 commuters. Okay. Then when we go to choose a dorm student, there's still 75 dorm students, but now there's only 99 people to choose from. So we have to change that second probability. Then in the next event, we have 75 out of 100 times 25. And again, my denominator changes to 99. And that is equal to, as a simplified fraction, 25 out of 66.